I will share my screen now. So let's see, where is my presentation? Always a challenge. Just give me a second. So, simplicity, I really loved that topic. And I will tell you why. Because everybody is searching for that one unified theory, right? That would be simple. And we all know how important that theory is for all of us. In Indic philosophy, philosophy of religions coming from India, simplicity is something that is appreciated all the time. And the thing is, the more complex things you see, that means you haven't really mastered the subject. For somebody to explain something very simply, somebody has to be a great master. So I really appreciate that talk, and it resonates with me. So let's talk about today AI and testing. I have approximately 30 minutes to do this presentation. Of course, I could talk about it all day long and still not be done. So what you can do is, if there's something else that you would like to see on whenever I'm presenting a topic, or you would want me to give more details, feel free to interrupt and ask questions. I will try to have my Q&A, looking at, I will be looking at my Q&A window so that if there is anything, then I can answer those questions. Let's quickly talk about, let's not worry about myself. Let's quickly take a look at this video. It's a dated video, nothing new, but the problems it represents, they are still there. You can clearly see that this AI model is trying to identify objects. And it can, at a time, identify only one object, it seems, one chair, one person. So not, different instances of the person. That's what it appears like, right? And the poor guy is trying to ask the model to pay attention to himself, to him, but the model is probably not paying attention. But something is happening here. Oh, now the model can actually detect two instances of the same object, meaning person in this case. So what's happening here? Well, as you have guessed, this picture is making the AI ignore this person or make the person invisible. Just imagine a small set of pixels can make an object disappear for an AI. Think of a security system. In the night, somebody walks in with a t-shirt having a print of this type, or maybe just some patterns of pixels, and the person becomes invisible to the AI. It's a real threat, and it is a threat. Meaning, most of the neural networks suffer from this problem where you can do adversarial attacks on those and find out those data patterns which will make the model misbehave, misclassify things, and so on and so forth. So while AI looks all powerful, there are a lot of issues. So if I need to test such systems, what do I really need to have? Skills for AI professionals, people say you need to have knowledge of statistics, mathematics, you need to have some programming knowledge, some AI knowledge, what are models and, what are various frameworks and libraries that you can use. But if I want to be an AI tester, what are the skills I should have? Nobody really has defined it, unfortunately. And that is the problem that I actually started grappling with in 2015 when I wanted to develop the first syllabus for AI testing. Actually, I didn't want to develop a syllabus. I wanted to understand for myself, how do I test AI models? And nobody was really looking at it. There was very little research that was happening. And after a year and a half or two of struggle of trying to create a syllabus, I threw the syllabus in the bin and restarted again. And then, it took me a year and a half with a few other people to create Word's first AI testing certification called Artificial Intelligence United. Later on, it was taken over by ISTQB, and this became one of the base syllabuses to create ISTQB AI syllabus, of which I am one of the authors. And that syllabus tries to define some of the skills that you as an AI tester needs. I'm going to talk a little bit about that. Now, I've been doing presentations on AI and testing since I would say 2017 or so. I used to do a lot of what is AI and then move on to what is AI testing. I'm not sure in 2023 if I should be doing what is AI and what is machine learning, but I still feel that the knowledge of AI and what is machine learning is not really as widespread as I would like it to be. Consequently, I would spend a little amount of time looking at what is machine learning, and then we will talk about how to test it. So what is machine learning? All this information, all this theoretical knowledge and definition, they are not really going to help us. So ignore this slide. Ignore the slide, but not what has come to the screen just now. If I ask you, if X is my input and Y is my output, what is the output for the last row, last column going to be? That question mark. So you would say, 1 gives me 1. There are a lot of equations that can satisfy when input and output both are 1. For example, 1 to the power 1, 1 divided by 1, right? And 1 to the power 0, and so on. But when you come to this next one, you say 2 and 4. It could be 2 into 2, 4, or 2 plus 2, 4. Then you go to the next one and you say, okay, 5 to the power 2. That satisfies the first and the second and the third, all columns. So this seems to be by far the best representation today. And by that, meaning right now, by that, 8 should give me 64. Now that is actually machine learning. You learn from your past data, and then you predict the output for the new data. That is machine learning. Machine learning tries to find patterns between input and output. So please take a look at what is appearing on your screen and try to answer what is going to be the output. X is the input, Y is the output. And if you do it quick enough and put it in the chat, that would be really wonderful. Anybody? So if you look at it, yeah, I'm looking for answers. Nobody wants to give any answer to this? All right. So I would say 12 divided by most people, that's how they come to it. 12 divided by 4 gives me 3, 24 divided by 4 gives me 6, and 36 divided by 4 gives me 9, and 52 divided by 4 gives me 7, and 81 divided by 4 gives me 9. Something is wrong here. So I go back, take a look. What was apparent as a relationship with the few data points no longer holds true. Now, what does it mean? It means maybe row 4, for example, or row 5, they contain corrupt data. So maybe row 1, 2, 3, they are, it has correct data, and all other rows have incorrect data. Or maybe I've missed a relationship which might exist, which will satisfy most of these rows. And indeed, there is one such relationship, which is that output is equal to sum of 2 digits of the input. So 1 plus 2 gives you 3, 8 plus 1 gives you 9, and hence 1 plus 8 will also give you 9. Now, this exercise has some of the most important lessons of machine learning, and I would like you to look at those lessons and learn them if you already do not know. So what are these lessons? More data, diverse data, gives you better experience, better predictions. So one of the most important lessons is that you should have diverse data, and you should have as much data as you can get your hands on. These are simplistic statements. If we have more time, I would love to explain where these statements do not hold. But for the moment, just please understand these two things. The more data and the more diverse data you have, better is your machine learning model. AI and ML, they are not one and same. AI is the broader thing, and machine learning is one way to do AI. So there are a lot of ways in which machine learning can be done: supervised, unsupervised, semi-supervised, reinforcement, and so on. We'll not really get into details of each one of those, but just understand, if I have data, which can be output of which can be labeled, for example, a cat, a dog, a car, or an object, we are talking about labeling, and we are talking about supervised. Unsupervised means no notion of labeled output. So if you have labeled output, then you can do supervised learning. If you have unlabeled output, you can do unsupervised learning. Let's not worry about semi-supervised. You can understand it somewhere in between. Reinforcement, when you do not have any data at all. And natural process-based. And reinforcement learning is something which which at one point of time, testing.ai showed a promise that it will basically make testers sort of redundant. And I'm making a big statement here, sort of redundant. But unfortunately, for whatever reasons, that hasn't happened yet. But I do look forward to, with latest changes in AI landscape with ChatGPT as one of the things, but there are many other things. Some of them I am working on as well, which will hopefully result in machine learning and AI testing the product by itself. So if a machine can learn to play a complex game like chess or Go without any human intervention, why it cannot learn to test? That is the basic premise. And the only reason today that I see, it's not technology, but it's the cost. A single game of Go, for example, costs AlphaGo $3,000 of electricity alone, right? So, testing using machine learning where no humans are involved, at least as of today, may be very expensive. But we'll, again, not go there today, some other time, hopefully. So let us first take a look at, creating a model very quickly. And from there, we will try to understand how to test AI models. So I will share my browser with you. And good question, where is my browser? Here is my browser. You can see, hopefully, my browser. This is a URL you all can access later, teachablemachine.withgoogle.com. And I am going to train a machine learning model based on images. So actually, when you go to teachablemachine.withgoogle.com, it takes you here, and I say get started. And I'm going to do an image project using standard image model. I wish I had more time to explain all of these things, but right now what's happening is the problem I'm trying to solve is that given an image of some animal, it has to be classified as whether it has a cat in it or a dog in it. So I'm going to have two classes, cats and dogs. And I'm going to drag and drop images here of cats and dogs. So you will see that soon. Now you can see that I have dropped some cat images, and now I'm going to drop some dog images, and I'm going to train my model. Now this is going to train a neural network, and the model has been trained, and now it is telling you that what you are seeing on the screen is actually a cat. So you're not seeing a human being. Guys, I'm in disguise. I'm a combination of 70% cat and 30% dog. Right? Can I change it? Yes, I can change how much of a cat or a dog I am to a certain extent. Right? Very nice. Now you see two things here. Outputs as percentages. Cat or dog as a percentage. Now you see I'm 50-50 cat and dog. Interesting. Anyway, let me try to see it with real cats and dog images and see how good my model behaves. And there was a survey just before my presentation, which was about accuracy and explainability and so on. I will try to touch upon each one of those. Now let us try to see how much of a dog this is. This dog is going to commit suicide because it has 21% cat DNA, it seems. How is it possible? Another dog, but probably it fares well for cats, 100% cat, right? So there are a lot of interesting things here related to cats and dogs, cats being recognized correctly, dogs not being recognized so much correctly, isn't it? Oh, wow, 50% cat, 50% dog. Now, why is that happening? If I know why that is happening by use of some tool, which can explain to me why the model is treating this as 50% cat and 50% dog. If I have that, either it would be because of interpretability or because of explainability. And explainability was another big problem. So so there were two main answers that were coming from people. One was accuracy, other was explainability and interpretability. So we'll try to cover that pretty soon. Now you have seen that. Now my question to you would be, how would I really test this? There can be infinite images of cats and dogs. Should I be using all of them? Are there any techniques that exist that can help me? Interestingly, there is one technique. I will put a link to that technique in the chat. That is a 2-hour talk I did a few years ago. It's a technique I had developed in 2001 something like that, and very useful for testing, either doing exploratory testing or writing test cases out of those, or for machine learning based test cases for machine learning based software. Okay, so how and all, maybe in just a moment. Now I will go back to my presentation, and I will carry on. I'll show you some of the techniques that exist today for testing AI systems. Now, what you saw was a two-step process, a training phase and a prediction phase. A training phase was when I gave input data, output labeled data, and I trained my model, and out came a model. Now, what's a model, etc., we can't talk about right now, but think of model as an executable or a DLL for a moment. And at this phase, once I have the model, I can test it. And this is what typically data scientists would be doing, testing your models. Unfortunately, they do not have, one, enough time, two, enough possibly understanding of testing to be able to do a very good job of testing. And I will try to explain where things fall. For example, how good is the model? What is the accuracy? What is the desired accuracy? How can I increase the accuracy? Those are some of the challenges there. Another challenge is that, the need for an independent testing. Is there such a need for this model that I have created? Most people don't want to accept the fact that there's a need for independent testing, and testing which is very specific to machine learning models. Well, anyway, once you have your model, you integrate it with the rest of the system, and then you give it new input, and then live input probably, and it keeps predicting the outputs. For example, how you do with ChatGPT or anything else. Now, there are two distinct phases then for testing. One, when my model has been trained and I test the model in isolation, and that I can call as offline testing, and then, or just model testing. And then when the model is integrated with the rest of the system, AI and non-AI, all components together, that I can call as online testing. This was supervised learning. We are not really getting into, as I said, other types of learning. Now, supervised learning is probably the most common type of machine learning that you see today, and hence we are stopping here with respect to that learning. Now, when I say machine learning or AI testing, what do I really mean? Actually, many things. I could be testing AI applications, right? Like I showed you the cat and dog model that we created. I could be using AI to help me in testing. For example, in writing test cases, doing some sort of defect predictions, or analyzing my source code, analyzing bugs, and so on. Or I could be using AI to help me in software development lifecycle. For example, assigning bugs, doing estimations, and so on. Or I could be using AI for automation, automated testing, which runs in two different directions. One direction is your normal automation, where you know what are the tests and you want the AI to automate those tests or help you automate those tests and maintain those tests. Other automation is automating testing itself, which testing.ai, for example, takes the tack, where they use bots to do testing. Jason Urban, and if you haven't heard of him, you should definitely look him up. He has written very beautiful blogs and papers on how to use AI in testing, what is AI, what is testing, and so on. You would really love it. Tariq King is another one you should be reading about. And they've created bots, for example, which can test your system automatically without giving them too much input and so on. Again, not a topic for today, but if you're curious, maybe we'll talk about it some other day. So what are the challenges if I were to test AI models? Well, one of the biggest challenges is Oracle availability. I do not know what the result of my test case would be, running the expected result for after I run the test case. For example, when I gave it an image of dog, the expected result could have been, oh, it's a dog. But it said 50% cat and 50% dog. Is that a bug? If it said 99% it's a cat, or 99% it said to a dog that it's a dog, but 1% probability of it being a cat, is it a pass or a fail? That's a question that you have to ask. That's the probabilistic nature. I didn't know why it called a cat as 50% dog or dog as 50% cat. That is lack of explainability. Have I covered all possible combinations of cat images and dog images? What were the requirements really? How do I determine coverage? How do I determine equivalent to code coverage? That's another challenge of testing AI models. How much data is enough? How much data should I use for training? I used just 3 images. Was that enough? Should I have used 3,000, 30,000, 3 million? That's the question, both from a training perspective and from a testing perspective. Let's not worry about skill requirements for the moment, because we all know how to test AI models, all these questions. Definitely there are skill challenges, both from a data scientist and tester perspective. Sometimes people use, and there are abundant number of models already available, VGG16, VGG32, Inception, YOLO. So, there are a large number of pre-trained models for audio, text, images, video, all sorts of data types for applying machine learning on them. Because these models are available, and if I were to train them from scratch, it would cost me hundreds of thousands of dollars, both machine time as well as availability of data and time and so on. So this is going to be a problematic thing. So people use pre-trained models. Now, what are the challenges? Because this is a big norm in machine learning industry, anybody who is doing AI testing should understand what are the challenges with pre-trained models and how do I make use of those. And then all things that we talk about, interpretability, explainability, ethics, and so on, fall under the purview today of AI governance. And AI governance has become a big issue. So these are some of the challenges, not all, some of the challenges to AI testing. So you want to become a master of machine learning and AI testing, you need to understand how to overcome these challenges. So what is the state of practice? Well, early days of independent testing, remember 2001, 2002, before that, mostly developers were doing their own testing. Way back in 95, when I joined the industry, I was a developer, and I used to write networking stacks and middleware and so on, systems programming. Then I moved into testing, last 26, 27 years in testing. And what I saw back then, right from 95 to 2002, people didn't understand the role of testing. After 2000, Y2K, basically people started looking more into role of independent testing and became popular. We are undergoing a similar phase for machine learning models. People are slowly coming to understand the need for testing the models using independent testing. So what's the process? How do you do it? What are the skills, roles, responsibilities, techniques tools, all of these things are developing. So where is some research happening? Metamorphic testing. Coverage for neural networks. How do I do coverage which is sort of equivalent to statement coverage, branch coverage, and so on? That is something that people are looking at. Whether it is useful or not is also a question that is being looked at. Bias and ethics form a very strong part. For example, if an AI, let's say, doesn't give you a credit card because of the area in which you live or because of your race, then that is an example of bias. If you are given lesser salary because you are female, that's a bias, right? So your model is as good as the data. So testers need to understand bias. Then you need to have tools to understand bias, statistical bias, algorithmic bias, model bias. So you need to look at all sorts of biases, source of biases, and how do you remove. You cannot remove 100% all the bias. That may not also be desirable. But as a tester, if you want to do machine learning testing, you need to understand bias, and you need to understand how to test for bias, how to remove wherever it is desired. Data is never enough. So a lot of tools are coming up which use AI to generate data, both for non-AI systems and AI systems. And this is something that you should be looking at. And some more research in governance and so on. Now let's quickly take a look at types of tests that are done. Metamorphic testing. A testing technique where you look at the outputs, try to find a relation between the input and the output, because you don't know what the expected result would be. You don't have an oracle. So what do? So you say, oh, for this input, this is output. Verify that this is correct. If I verified that this is correct by some means, then if I change the output in some way, change the input in some way, I understand how the output should change. For example, if instead of buying one thing, if I buy two things, what is the relationship between output and input? The output should be, meaning the cost of thing should be at least 2x, possibly a little less or a little more, depending on whether the thing is in premium or you want to give discounts, right? So basically, you're looking at that kind of thing. So, for example, a program that determines average of a set of numbers, I know a relationship, metamorphic relation between input and output, that if I change the order, average should remain same. If I double every number, then what should happen? Same expected result, right? You would want the average to be multiplied by 2 and so on and so forth. So essentially, what you are looking at is a relation between input and output, which you can use to test, especially when you do not have an oracle. So metamorphic relations have to be identified from the domain by the people who are testing it. So it doesn't need AI knowledge. It doesn't need machine learning knowledge. It requires domain knowledge, understanding of input-output behaviors. Then there's back-to-back testing. You create a pseudo oracle and then basically compare the result of your ML system with a pseudo oracle system. And then you have, you can look at the slides later. Then you have A/B testing, which is again a statistical technique, nothing new, but you can use that for machine learning testing also. And one technique that is not described here, which is linguistic analysis-based method, which I developed. I will give you a link for that, and I'm 100% sure you'll find it very interesting. Now, when do you do these three testings? Metamorphic testing, A/B testing, and back-to-back testing. Back-to-back testing when you have a pseudo oracle available. Metamorphic testing when it is possible for you to determine the input-output relationship, and A/B testing when you have a past version available and you compare it with the new version or something of that sort. So you can select test techniques. As I said, there are other techniques also. Take a look at adversarial testing, and I'll give you an example of adversarial testing very soon. Test for data-wise testing, you can do experience-based testing, exploratory testing, and you can also do pair-wise testing and so on. Explainability, many methods available. For example, LIME. I'll not get into LIME, but let me show you an example of GradCam. What you see here for a neural network, GradCam is explaining to you which pixels resulted in tilting of the output towards one class. For example, if you look at the top image, last one, it shows you that the hind legs of the cat were instrumental in classifying it as a cat, whereas the face of the dog was instrumental, all the red marked pixels was instrumental in classifying it as dog. Now, if you are satisfied with this information, you know the model is behaving correctly. Otherwise, let's say it is because of the blue colored or the black stripe that you see on the dog, which helped it marked as a dog, you would clearly know that this is incorrect. There is something problematic here. So this is an example of explainability. A lot of different explainability methods are there. Then there are, I'll just like to talk about automation tools. Just two examples that I have here. 21labs.io, I don't even know if it continued to exist or not, but at some point of time, they were doing really nice automation tool. No, I don't get anything from them or from Apply Tools. Apply Tools was also very popular. There are a lot of tools that are available to do that kind of testing. Test.ai, I think that was it, right? Or testing.ai was the one that developed a grounds up AI-based tool. You can take a look up their website as well. So, this is a question, but before I go to that question, open the floor for question and answer, I would like to show you one more thing. Let me show you a tool that we have developed as part of my company called Test AI-NG, or we have a tool called AI Ensured. And I showed you all of these different types of testing. Well, you can see many of these types of tests here. Data analysis, where we are looking at whether there is bias in the data or not. And explainability. Now here, for example, we have explanations. So this is an explanation. For example, actually it was a giraffe, but it was being predicted as a deer by model with 68% confidence. And definitely this is a problematic area. So when I applied GradCam++, so my tool applies many different techniques for explainability. It shows me that, some sort of stems of the trunks of the tree with a lot of greenery, that is being recognized as a deer. Now, if I understand that, then I can actually go back to my data, verify that, and I would find that indeed my deer pictures are with a lot of greenery and trees. So it is actually recognizing greenery and trees as deer rather than deer as deer, which means I should include more images of type deer with varied backgrounds, white background, solid background, snow background, urban background, whatever, different backgrounds. And then it will start recognizing the deer as deer rather than, a particular pixel pattern of brown and green. So our tool, it just takes data and model as the input, and it produces this report as an output where you can see all the places where it failed to recognize things properly and explainability for those. There are various explainability techniques. I talked to you about adversarial attacks, and our tool does adversarial attack as well. For example, in this case, horses were being predicted as horses with 82.7% confidence, whereas once we modified the data, and you cannot really distinguish between the left and the right image, but it started predicting these as deer. So we generate a lot of different, based on different algorithms, we generate a lot of adversarial attacks. And interestingly, these adversarial attacks can now be used to train my model. So I take these adversarial images, feed it back to my training data, saying this is actually a horse, and then the system gets cured of its adversarial attacks. Metamorphic testing, you can see here that we've done a lot of metamorphic testing, and we have found places where elephants are, for example, being recognized as something else, and so on. So a lot of metamorphic testing, which includes things like taking an image, zooming it, zooming out, zooming in, and so on and so forth. So we've discovered a lot of other corner cases by blurring of images, by changing the contrast, rotation, shear, blackouts, and so on and so forth. And then we take that data, we train the model again, and you would find that once we have trained the model, the accuracy increases as compared to the previous one. Okay. Then you have model privacy attacks. So these images have been regenerated after doing a privacy attack from the model. And then there are non-functional tests on the model that need to be performed, like performance and size and so on. So all of these are different tests that, for example, our product can do. It supports a lot of different pipelines. So I showed you how would you test an image pipeline. Similarly, you can have an object detection pipeline. I'll just show you one where you are detecting various objects, and you can do metamorphic testing on this. You can do explainability on this. You can do attack vectors on this, and so on and so forth. With that, I am closing my presentation for right now, but I am open to questions. Looks like I was either too good or too fast.
Too good. Yes, too good. But we have a question from Bilal Öksüz. He asks, AI have any security issues used in QA process?
A lot of security issues. So, for example, if I can, by providing a model which is trained on poison data, I can have model do all sorts of interesting things in production. So that is one. Second, if I have a model and I can do an adversarial attack on it, then I can do model something. I can do model whatever I want the model to do. For example, there was this experiment that was conducted where a stop sign, people put just 2 or 3 black stickies, rectangles of certain size at certain specific places, and the driverless car image recognition saw that sign and interpreted that sign not as a stop sign but 45 miles per hour sign. Now you can imagine what you can do with such things. So those are some of the security issues. Then data privacy. So if I can extract data, and some experiments have been done and shown that you can actually extract some data out of models, possibly some social security numbers, or credit cards, or reconstruct some of the images which have been used to train the model and so on. So there are data privacy issues also. But now I talked to you about pre-trained models. Now, there are bias-related issues in models. For example, if a model is biased against people of certain color, skin color, and you take that model because you are not aware that it has those biases, and you include that model in your own machine learning model, you do something on top of that model, then it becomes a problem. You inherit those biases, so you are likely to get sued or have very adverse reaction from the users and so on. If there are security issues using adversarial attacks, you inherit those as well, and then your model can be compromised and so on.
Thank you. Now we have another question from Arzu Yayla. Does AI testing have same test case creation techniques as software testing?
AI, from a machine learning perspective, this could be a bigger answer depending on what definition of AI you use. But specifically, when we talk of machine learning tries to create test cases based on what inputs you have given to it earlier. So it doesn't recognize test case design techniques because it tries to identify patterns and so on. But large language models, for example, ChatGPT, they basically have the knowledge of various test design techniques also. So you could ask it to generate test cases based on, for example, state transition diagrams by giving it maybe state transition diagrams or tables and so on, equivalence partitioning and boundary values and so on. So you can design test cases. So essentially what you're doing is you are asking machine learning to think like a tester using test design technique and generate test cases. But there is a different way of doing testing, which is, for example, using reinforcement learning. In reinforcement learning, you let the model loose on the on the software, and it tries to follow all different paths. Every time it hits a bad path, you give it some negative, I would say, a penalty, right? So you give it a penalty. And if it does the right thing, then you give it a reward. And sooner or later, the model learns to navigate the entire software. Now you don't need to do anything. It can take a lot of different input, navigate the entire software, and anytime there's an error, and it would have learned what an error really means, it can actually do brute force kind of testing. So there's no test design technique being used here. However, you can make it smarter because if you keep training it, and it will learn a lot of new things. Now, what is good, what is bad, that's a separate thing. A third way of using machine learning to design test cases is, for example, doing analysis of requirements using a large language model like ChatGPT. And you can also train a ChatGPT kind of model by saying that for this requirement, these are the test cases. For this requirement, these are the test cases. And based on the quality of the test cases that you have taught it on, it will actually generate test cases for you. And then finally, there is a technique that I am working on. There's research that is going on where we take, for example, visuals of the requirement. So the requirement is a visual requirement. I draw things, and then I analyze using image analytics to see what are the objects that are there and what are various properties of the objects and how they interact with each other, and I generate test cases. As I said, this is a research topic, but then you can generate millions of test cases using it. I am going to put a link to that talk of mine in the chat here. Meanwhile, you can ask next question if there is time.
Okay, so there are 3 more questions, but we are running a bit late. So I'm going to ask what I really would like to have a kind of short answers for them. So Suzan Özgür asks, is it a suitable method to generate test data sets using generative adversarial networks, for example, to test image-based classification models?
Wonderful. What you saw, the demo that I gave you of our product, actually generates using GANs a lot of test data. But initially, you have to give it some data on which GANs can work. Is it useful? In addition to the product, I also have the same company doing services where we test ML models for different companies. And we have found that our GAN-generated data is very helpful in cases of images. In cases of, there is a bit of thing there that it took us a lot of time to get this right. Still, when we generate test data, for example, for tabular data coming from databases, one of the challenges is understanding domain constraints. For example, for medical domain, let's say, your sugar readings. If I generate test data and my model generates negative test data, I need to understand that you cannot have negative sugar readings, and then I need to remove that from my generated test data. So, but it is very useful.
Okay, so I'm going to ask one more question. How can we integrate sustainability in the area of AI? It's from Diane Yagbeir. I don't know if I'm saying it correctly, but the name.
Sustainability is a big question, and unfortunately, and please don't mind it, but I have a big criticism of Western way of looking at sustainability, where you pick up one variable and you want to basically reduce that. For example, you pick up one variable saying carbon. Let's reduce carbon footprint. You pick up one word, sustainability, and then you ask yourself, how is this going to be sustainable? Sustainability is not something that you can address point by point. It has to be part of your life. So much that you forget the word sustainability, because by very nature, what you do is sustainable, and hence you don't even need to talk about the word sustainability. So, but since we are talking of sustainability, one of the biggest challenges of AI is the cost that you incur in training the models. The larger data set you use and the more powerful models you want to create, more computing power you need, and if your computing power is coming from greenhouse gas emission, you know that's one of the biggest problems. So many people working on collecting the data and so on. So sustainability in machine learning requires collaboration at the level of society. Otherwise, piecemeal things, they don't really work. At least in my opinion, because I come from a country where we didn't care about sustainability, the word. However, we were sustainable, never cutting green trees, for example, recycling things to the end, but we never talked about it because every little thing that we did was sustainable by itself. I don't know if I made sense to you, but it's probably a very big cultural thing, and it's more to do with thought process and philosophy rather than actual act itself. Because once you get the philosophy and the thought process right, slowly and slowly the acts also become right.
Thank you so much for this remarkable presentation of you, Vipul. It was really nice to see you here. It was really so good to see you and meet you here and make you a part of our community as well.
I
Thank you
appreciate
for
your
the time.
Thank you so much.
Thank you so much. Have a nice event. Have a nice conference. We would like to see you here for the rest of the conference as well.
I will try my best. Thank you so much.